Okay, so here's variation problem number 3 for our guy holding the pole. And so here's the situation in this case. Both the man's hands are well to the side of the center of gravity. Okay? And again, we can consider the entire mass of the pole as far as calculating torques and that type of thing. We can consider the pole's entire mass is at the center of mass. And that's where gravity acts with the force of mg. And as we calculated previously, that's 49 newtons. Okay? So here's our right force, here's our left force. And what we're told in the problem is that man's left hand is 1.6 meters from the center of gravity. Okay? Now, if the man's hands are separated by 0.8 meters, that means this distance here to where the right force, his right hand is 2.4 meters. Okay? So there's the setup to this problem. Okay? So we have his right hand and his left hand. Okay, now we need to apply our equilibrium conditions again here. And those conditions again are that the net forces have to be 0. And also the net torques. The net torque, all the torques have to add up to 0. So let's apply this equation first. Okay, and again, the upward direction is positive, the downward direction is negative. So we have two positive forces. So, and all these forces have to add up to 0. So our right force is one upward force, our left force is the other one. And then we have 49 newtons downward. All right. So there's one equation here for that's helping describe equilibrium. Now let's apply our torque expression to this situation. Okay, and again, we can pick any pivot point we want on our object. And the pivot point that's probably easiest to pick for this problem is that one right there. Okay? Our little point right there is probably the best one to pick. Because, well, weight acts right there, and weight is acting on the pivot point, it therefore has 0 torque. Okay? So the distance of this force from the pivot point is 0, and by our torque expression that means 0 torque for this guy. We only need to consider the torques from the left force and the right force. Okay? And we're going to pick clockwise. Clockwise is our positive direction. And both these forces are clockwise torques. So these both give positive torque in the way we've set this problem up. So the torque from this guy is the right force times its distance from the pivot point, 2.4 meters, plus the torque from this guy, also a positive clockwise torque. That force, and the distance from the pivot point is 1.6 meters. And that has to add up to 0. Okay? So if we subtract this from both sides, you get that the left force, 1.6 times the left force, equals negative 2.4 times the right force. Okay? Now what we're going to do here, again, we have two equations, one equation here, two equations total, with two unknowns, our left and right force. So we're going to solve this for the left force and plug it in here. Okay? So, and again, this is a video here, so you can just back up if there's confusion. Divide both sides by 1.6. That gives 1 over here. Negative 2.4 divided by 1.6 is negative 1.5. Okay? So we haven't even solved the problem yet. And we already have somewhat of an interesting result here. The left force is the negative of the right force. So what that means is one of the forces is up, one of the man's hands is pushing up, the other hand is pushing down. Okay, and we'll see which one when we do this problem, finish up this problem here. Okay, so we've set the problem up as these are positive forces. So in our answer, if one of them is negative, that means that's the downward force. Okay, so let's plug this in here. So we get the right force plus the left force. So the right force plus negative 1.5 times the right force. That gives you negative 0.5 times the right force. Okay? Minus 49 newtons equals 0. So add 49 to both sides, and this then equals 49 newtons. Okay? Now solving for the right force, multiply 2 by both sides. Actually multiply negative 2 times both sides. And you get the right force is negative 98 newtons. Okay? So we're seeing that the right force is the one that's downward then. That one gives us the negative answer. So the man's right hand is actually pushing downward. Okay? So that man's arm is actually pushing downward right there. Now the left force is negative 1.5 times this. And that gives you, the left force is positive 147 newtons. Okay, so the left force then is actually an upward force. Okay? So think about this for a second. If you're holding some pole and it's the hand closer to the center of gravity is the one that has to push upward. The other hand has to push downward. Okay? And these are pretty big forces actually, so it's much harder to hold onto this pole far away from the center of gravity. Okay? So this is twice the weight of the pole. This is 3 times the weight of the pole. Okay? So when the man's holding it like this, his left arm has to be pushing up with 3 times the weight of the pole to support this pole. But in order to keep that situation stable, his right hand has to push downward pretty firmly with twice the weight of the pole. So 49 newtons, that's 10 pounds or so, give or take. So if this pole weighs 10 pounds, he's having to push up with his left hand with 30 pounds of force, while pushing down with his right hand with 20 pounds of force.